ENSO and stronger IOD. Okay, I think almost same. Yes, you can stop.
Yeah, thank you, Behera. Give applause for his talk.
So I have some slides maybe on predictions, but not in this. It's okay. I think can just leave it. Yeah.
Yeah. I think Behera already saw us from the basics of the solar radiation, explaining what happened with the variation, especially the climate variability, and showing more importantly how is our climate projections for the coming years. And it is very interesting actually, and I believe for students a bit difficult to understand it. But anyway, before I giving to the student and the lecturers, it's very interesting when you see the interaction between the IUD and ENSO, and some is occur at the same page, but the others no. So how is the main dominant factors for the teleconnection of this kind like this occurrence, this interaction?
Yeah, basically it depends on the mean state. So the Indian Ocean and the Pacific Oceans, they have different mean state in different models. Most models are not able to capture the observed mean state. So they have their own kind of mean state, and depending on their mean state, we can experience whether we'll have stronger connection between the two basins or weaker connection between the two basins. Basically how the SST gradient and the Walker circulations are maintained in the two basins. If the two Walker circulations are not so much coupled, those models will predict less in co-occurrence of IOD and ENSO. If they're strongly coupled to two basins Walker circulations, then we can expect more co-occurrences of ENSO and IOD.
But considering between the Pacific and Indian Ocean, they have equatorial regions, right?
Yes.
So how is the teleconnection actually relate with crossing with the equatorial that we believe by physics it is very difficult, right? So say like what is the more dominant factors from the atmospheric or from through the ocean?
Both. So the atmosphere is actually so we have the atmosphere, global atmosphere. Okay. So the gradient in SST, that's maintaining the Walker circulation, right? So if there is any change in the oceanic state, that will affect the Walker circulation in the both basins, this side and that side. As you can see that because of the warming, especially in the Indian Ocean, because of the warming, the thermocline is shallowing on the eastern side and deepening on the western side. The basic state itself is changing in the Indian Ocean. The basic state here, like this one, so we have shallow here and deeper here. This is the normal state with the positive IOD state. So the climatological state is coming closer to this one. This side is getting shallower, this side is getting deeper because the Arabian Sea is absorbing more heat. And also the dynamics, Indian Ocean dynamics is helping the western side to accumulate more warm water. So that's why the basic state is changing towards a positive IOD state. And if that happens, the Walker circulation we'll experience in the future will be something like this. So we'll have more subsidence on the Indonesian side, which might get decoupled from the tropical Pacific, where we can expect, if it is a La Nina state, if it is La Nina or Modoki, then it might get strongly coupled with the Indian Ocean. But if it is El Nino-like state, then, if it is La Nina, then they get decoupled. If it is El Nino-like state, then they will get more coupled.
Yeah, from the illustration actually, they always give the goddess, right? They give like a wind burst. I mean, atmospheric is more dominant, but not because I'm physical oceanography, but I was thinking that kind of like a projectness and microwave theory.
Yes.
I think that's coming from the ocean. Planetary wave is playing
Yes.
more importantly,
Yes.
and together with the meridian opportuning circulation,
Yes.
something like that.
Yes. And one factor which is very much unknown to us and which is kind of we don't know how it is going to contribute in the future. That is the Madden-Julian oscillations.
Yeah.
If you have more Madden-Julian oscillation, then the water will get mixed.
Yeah, we're feeling by years coming is
Yes.
like stronger.
Yes. And there is strong association between MJO and Indian Ocean Dipole and MJO and El Nino. So if you have a strong MJO happening together is positive IOD, that will kill the IOD. Same thing, if you have strong MJO coming into the Ocean Pacific, then you can have El Nino.
Okay. That's good. So I give to the floor if they have questions. Bu Mega normally doing with the ENSO with this fish migration, tuna migrations. Do you have question, Bu Mega?
Yeah, so more in the Indian Oceans, but why the ENSO is more familiar? The impact also more strong than IOD?
Yeah, for the projection.
For the projections,
Especially in the Indian Ocean, why they affect like ENSO. Your projection actually for the coming futures is ENSO stronger than IOD, right?
yes. Mainly because most of the models are capturing ENSO better than IOD. Most models don't capture IOD in the future climate well. So that I think the projections are somewhat biased in that sense. If you look at the present state, present decadal change, it says that probably the Indian Ocean dipole will have more impact compared to the El Nino, if you see at the present state. But the models are somewhat biased to the El Ninos. So that's why we are experiencing more impact coming from the El Ninos.
So your projections mostly based on kind of like a climate shift or?
Yes, yes,
Oh, okay.
yes, yes.
Okay. Let's understand. Is there any? Bu Kurnia, maybe? No,
Yeah.
not him, Bu Kurnia.
So you can see here, like, I didn't have the 2019 chlorophyll chart here. So if you see 2019 chlorophyll chart, when there was no El Nino, the impact was very strong on the Indian Ocean side. This is the negative IOD when you have less chlorophyll. This is the positive IOD when you have more chlorophyll. This is the case for 2015 when we also had an El Nino. But if you compare this one with 2019, we didn't have any El Nino. But still we have very strong upwelling and the phytoplankton there. And if this happens in the future, then impact will be stronger by Indian Ocean dipole compared to El Nino.
A bias, yeah.
Yeah.
So Bhumika Syntax App also will have your project for giving this kind of like chlorophyll
Yes.
also
Yes,
give.
yes. And I didn't show you the predictions and what we are doing now. Like we also have climate models which are predicting what will happen in next month and 1 year ahead, 2 months ahead, 3 months ahead, and 1 year ahead. And those predictions can be useful for like predicting this kind of chlorophyll based on the model predictions. We know that when we have Indian Ocean dipole, the chlorophyll is higher in the Sumatra region. So models are already predicting 6 months ahead we'll have positive Indian Ocean dipole. So 6 months ahead we can predict the chlorophyll. That's what we are doing now. Same thing, El Nino has some influence on the western side, this side, on this side.
Oh.
So that also we can predict. Because of El Nino we have higher, because this was El Nino year 2015, so this side also high chlorophyll.
Why in the Western tropical Pacific
It's
you have
upwelling. Yeah, upwelling.
because you also have a lot of data over there.
Yes, yes,
Already?
yes.
Because
That
of
can
jump
also be
cyclone
predicted
there.
based on El Nino predictions.
Okay. Yeah. They're
And
in the
the-
wormful region.
Yes.
Okay.
And the idea is because we have the models, we have the predictions, In some sense, we can make a digital twin. Digital twin is like including all your model results, observations, and make a very nice interface, which can be used by anybody, not only researchers, but anybody, fishery people, farmers, policymakers. They just go and click something, okay, if this happens, what will be the scenario? You can create your scenario based on that. So that's the idea, to create digital twin. We have the models, we have the observations, we just need an interface, good interface, smart interactive interface, and together we can make it a digital twin, which can be used by everybody. I think your project can be first digital twin.
Oh, thank you. Right.
So how about the time scale? Is it daily or monthly, the forecasting?
Depends on your requirements. At the moment, climate forecasts are monthly, but you can use AI machine learning to downscale to daily. And also you can use weather predictions, like daily weather predictions, to predict what will happen like 5 to 10 days ahead, 1 week ahead, 2 weeks ahead, using weather predictions. Using climate prediction, we can say what will happen 3 months ahead, 6 months ahead.
You need downscale, yeah?
Yeah, we already have the predictions from both systems, weather prediction and climate prediction. We can also do the downscaling for local regions. Yes.
Okay.
Both statistical and dynamical.
Yeah. Bu Kurnia, maybe you have questions. This is a student of ISCAP.
Yeah?
You know.
Okay. Where is he now?
ISCAP. Lectures here.
ISCAP.
ISCAP in the become the in the University of
Sriwijaya.
Sriwijaya, yeah.
Yeah. Okay.
Yeah.
Sumatra.
Okay.
Okay. Good morning.
Good morning.
Prof. Behera. Thank you for this opportunity, Prof. Padli. Actually, okay. Thank you very much for this opportunity. Actually, I don't follow all this lecture, but for my research right now, I also concerned with the IOD and ENSO in Southern Java Sea. And right now, I have research using the satellite data and model with the parameter like chlorophyll and SST, something like that. And also using the biological parameter like eupotic depth. And I see in this result, maybe you can give me suggestion like that. In that result, we now the IOD and ENSO give the influence with that parameter. Maybe you have like suggestion what the most
climate drivers.
Climate drivers for the apotic zone and chlorophyll. Thank you.
Did you get?
Yeah. So the idea is you are already using the IOD and ENSO index to understand the impact on euphotic zone, and also what is going to happen in future. That's the question.
Yeah. What your suggestion for this connect to understand what is the most dominant climate drivers on this region, South Java.
Yes. So as I said, depending on which region you are taking. South Java. So for South Java, I think the Indian Ocean dipole is the strongest driver. Also you should take into consideration the Australia, the monsoon here.